All right, algebra nerds, we're ready for higher degree equations, example number 3. So again, this would be considered a higher degree equation because of that fifth power. Our variable is to a power higher than 2, all right? So for our purposes, that's considered a higher degree equation. If you go through the steps that we talked about, simplifying, there's no fractions to clear. There's no distributing, and there's no like terms that we can combine. Maybe that'll happen on a future example. We're starting with the easier ones. You'll notice again that the variable x is in only one term, so therefore we can again use the inverse operation approach, as outlined in examples 1 and 2. If you haven't watched them yet, please go back and do that. These are in sequence, all right? So anyway, in the order of operations, in reference to x, the furthest operation from x would be that subtraction of the 85. So again, we would use the inverse operation of add 85 to move that over basically to the other side of the equation. So now we have 2x to the fifth power equals 85. These steps are just like examples 1 and 2 thus far. All right, and then in the order of operations, don't you do exponents before you multiply. So there again, that multiplication by 2 would be the next operation that we need to remove. And so that leaves us with x to the fifth power equals 42.5. All right. So now what? Well, just like the first two examples, I would suggest here you stop and think about the possible values of x in terms of positive and negative. All right. So let's think about it. If you put a positive number in for x and raise it to the fifth power, positive numbers raised to any power come out positive, and 42.5 is a positive number. So I'm thinking, yes, positive is going to stay on this one. These are all different behaviors, examples 1, 2, 3, and 4, all right? So yes, positive makes sense. Negative. When we raise a negative number to a fifth power, and I want to remind you or point out that a fifth power is an odd power. So do you remember on assignment number 3? Oh yes, it was incredible. I agree, back before spring break on assignment 3, we talked about that negative numbers raised to odd powers come out negative. And looking at this, you would hopefully then say, you know what, that x cannot be a negative number. It's not a negative real number. So that isn't going to work. So this time, just the positive is going to work. All right, so then, once we've reasoned that out, we then would say, well, what math operation gets rid of a fifth power? And you would apply a fifth root to both sides. All right, and so there you go with that. And that gets rid of this and leaves x. And then now you're looking at me and you're probably saying, well, Mr. Soggy Waffle, I can't find my fifth root key on my calculator. Can you come to my house and help me find it? Sorry, I can't do that, all right? But I've got a better plan. That 42.5 is to the first power, and so again, using the definitions of radicals, we can change that into 42.5 raised to the 1 over 5 power. Remember that, all right, 1 over 5. Put that in the calculator, again, making sure to use your parentheses. I'm sorry, but my virtual calculator is probably difficult for you to see. We have to be patient with each other as far as, you know, the things we have to change given our circumstances. But if you put 42.5 in parentheses and raise it to the parentheses 1/5 power, the calculator will spit out 2.12. And again, I want to note to you that the instructions on this series of examples were to round to 2 decimal places, and I've done so. So this is approximate, and our solution set, therefore, only has one real solution. And unlike the other 2 examples, that's the only one. So again, these are different behaviors depending upon what's going on with the power and all that. So let's go back to the behavior of roots and add the next scenario. This was example 1, this was example 2. What's going on example number 3? Here, we had an odd root of fifth power, which generated a fifth root at some point in the process, and we're applying that odd root to a positive number. And again, that number under there is called a radicand. So if we apply an odd root to a positive radicand, just like we discussed on this example, that's only going to create one positive real solution. All right, so that's example 3, and we've got one more scenario to talk about with example 4 very soon. Go get yourself a cup of coffee or whatever, and we'll see you soon.